Hello, and welcome to our final workshop number 15, denominated anchor analysis. Since we already opened the database and we have our load cases checked, we can go right into setup for the analysis. So we're just gonna click on under analysis right now. And now that analysis has been selected, we're just gonna go and run a full run on the entire model. And in translation parameters, we can go and check that we have XDB and parent selected. Our solution type is going to be linear static, as everyone knows. And we can go ahead and apply. Now that the meshing has been made and the analysis has been attached, we run the analysis with our linear static solution. And after this, we're going to click on subcases. And we're going to select the default for available subcases. And it should be selected in available load cases as well. I'm going to click apply. And yes. And we're going to click OK. And they're going to rerun our analysis. And the black box is doing its thing right now. It's running the analysis. And it's done. So we're going to access our results by by selecting access result and attaching XDB. Select result file and go to anchor XDB. Once it's attached, we click OK and apply. And we have attached the results. Now we're going to go results, create, and deformation. And we're going to select display this SEC1. And we're going to display displacements translational and click apply to see our results. And that blue and that white is the deformation caused by the pressure applied onto the pinhole. Now, if we only want to see the deformed shape, we click display attributes and we're going to click wireframe as render style. We're going to deselect the show and deformed and deselect the and click apply. And now we're going to go into our home in the plot erase section and click erase for geometry. So this is all the undeformed section, the deformed section, Now we're going to go into our results again, and we're going to create a fringe deformation analysis, and we're going to see the stress tensor in von Mises. And this is the information we can see. And I'm going to zoom into the areas of greater stress. So the areas of greater stress are obviously the thinnest areas in the interior part where the pull has been generated, and the areas of least stress are towards the outer edges of the base material, which has practically no pull on it. And now we're going to click on target entities, and we're going to select elements as the target entities, and we're going to select the whole top part set display image for faces and click apply. So this is the area of greater stress, and the higher stress region is in the inside. Obviously, it's not as detailed as we'd wish because of our lack of a complete MSc Nastran Patron program, but we can see clearly where the greater stress is applied. Now we're going to reset it and apply it so we can see everything. And now we're gonna create another fringe and click the plot options icon, which is letter C, and select as a domain. We're gonna select none, and the method is gonna be derive average. For intra element within element, so we will select the shape fn for the extrapolation. And then the target entries, we're going to select current viewport. Then we're going to click apply. And we can see a different type of stress generated. Differently represented, but actually very similar to what we had before. And that's our analysis for the anchor made with the XDB files. In conclusion, we can see that the loads applied and the constraints made were designed for the sustainable use of this anchor through time, and of course the areas of greater stress highlighted in red and orange are minimum, while greener and more bluish areas are the standard in this. Thank you.